And moving on to the next problem, here three concentric metallic cells A, capital B, capital C of radii, a, small b and small c. And they are given A is less than B is less than C have the surface charge density plus sigma, minus sigma and plus sigma respectively. As shown in figure, they are given the figure. If cells A and C are the same potential, and this is the keyword for this problem. If the cells A and C are same potential, then obtain the relation between the radii A, B and C. Okay. Now this is a diagram they are given. The first sphere which is having the name as capital A, which is having the radius small a, and the second sphere which is named as B, which is having the radius of small b, and third sphere which is named as capital C, which is having the radius of small c. And what they are given, if cells A and C are same potential, then we should calculate the potential of this sphere as well as the potential of this sphere C. When we are going to calculate this sphere, that means sphere A, we want to calculate, then we should add account of these two spheres, sphere C as well as sphere B. Why? In the sense, this sphere lies inside this B sphere as well as C sphere, right? So we need to take an amount of B as well as C, add with this A sphere. And if you want to calculate the potential of this sphere, C sphere, then we should take an account of B sphere as well as A sphere. Why? In the sense, this C sphere lies outside because lies outside both A sphere as well as B sphere. And now move on to solve this problem. As we know that V is equal to 1 by 4 pi epsilon naught Q by R. Now we are going to calculate the potential in A cell. So 1 by 4 pi epsilon naught Q divided by, what is the distance they given? A, right? Okay. Now what I am going to do, this is for sphere A, right? As we know the general formula, Q is equal to sigma A, where sigma is surface charge density and A is area of that particular shape. Now whenever we are going to calculate this one, what I said, we should add account of this sphere as well as this sphere. Yes. So what I am going to do, I am going to add QB plus QC plus divided by C. Why I am considering this equation in the sense, 1 by 4 pi epsilon naught QB by B is for second sphere. 1 by 4 pi epsilon naught QC by C is for third sphere. I am adding up all together, that will give the electric potential of this sphere A. And now, as I said, Q is equal to sigma A, right? Yes. So I can write 1 by 4 pi epsilon naught. Instead of QA, I can write sigma. So here it's given the charge density sigma for this A sphere, and area of sphere is, as we know that, 4 pi r square, right? Yes. Here this radius is for here is A square. So divide by A. And what is the charge density for sphere B is minus sigma 4 pi B square by B, and similarly C plus sigma 4 pi C square by C. So if you are simplifying it, 1 by 4 pi epsilon naught sigma 4 pi A minus sigma 4 pi B plus sigma 4 pi C will give. Yes. Okay. And what are the other common factor? Here we have 4 pi, and here we have 4 pi, and here we have 4 pi. So let's take outside. So 4 pi divided by 4 pi epsilon naught sigma A minus sigma B plus sigma C. So if you cancel over it, it will give, let's take sigma as common. Sigma is equal to A minus B plus C divided by epsilon. This is for the electric potential for the case of at the sphere A. And similarly, we should calculate. So here I can written VA is equal to sigma by epsilon naught A minus B plus C. Now we move on to calculating the electric potential at the sphere C. So at C we need to calculate. Yes. So again we are going to calculate 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught QA. Okay, what we should use here? We should use A or C, because we are going to calculate this big sphere. Yes, C is having the radius of C. So instead of A, we should use C. And similarly for second sphere, QB by C plus QC by C. Yes, and again I am saying that Q is equal to sigma A, right? So substitute. So Vc is equal to 1 by 4 pi epsilon naught. So Q can be written as 4 pi A square into sigma by C, plus here the charge density is minus, so I am using minus 4 pi B square into sigma divided by C, plus 4 pi C square sigma by C. Yes, and simplifying it inside it, 1 by 4 pi epsilon naught, and inside if you are simplifying anything you can able to simplify. Yes, you can take it out. This 4 pi, yes, you can take it out common. So 4 pi you can take it outside. So remaining we will have A square sigma by C minus B square sigma by C, and here C square C will be cancelled. Only we will have C sigma, and we can cancel over this 4 pi and this 4 pi, so we will have 1 by epsilon naught is equal to, here we can take an account of all the sigma, right? So let me take all the sigma outside. So A square by C minus B square by C plus C. This is the electric potential in the outer sphere. Okay. Now what they are asking, obtain the relation between the radii A, B and C, and we can write down Vc is equal to sigma by epsilon naught A square by C minus B square by C plus C. Yes, okay. And now what they given, cells A and C are equal. Now we should equate these two equations, right? So VA is equal to VC as they given. So we found the value of VA. VA is equal to sigma by epsilon naught A minus B plus C is equal to sigma by epsilon naught. Here you can write A square by C minus B square by C plus C. So here we have the common factor, so we can cancel over, and here we will have A minus B plus C, and here we can write A square minus B square whole divided by C, because of both having the same denominator, and plus C, and this plus C should come to this side. Therefore A minus B plus C, this should come to this sense minus C is equal to A square minus B square by C, and this term will be cancelled over. Only we will have A minus B is equal to A square minus B square by C. Just cross multiply this C. C into A minus B is equal to A square minus B square, right? So again C is equal to A minus B, which is in the form of A square minus B square. So we can write A plus B into A minus B. Now we can cancel over these twos, and C is equal to A plus B. This is the relation between all the radii A, B and C.